Hello everyone. In this video, we're going to talk about waves. Talk about waves. I decided not to use the slideshow type of presentation for this because there are lots of pictures here, and just doing it on this will lead to a better understanding of, especially of this topic. So, what is a wave? A wave is a disturbance. It's any disturbance through a medium that transfers energy and momentum. Okay, so wave is a type of disturbance which transfers energy and momentum. Okay, so like a wave on the water, when it hits a rock, it causes the rock to move. So it transfers this energy. Now there's some things that you might need to know about waves. So let's see, this is wave. So over here, this part of a wave, the maximum of the wave is known as the crest, and the lowest point on the wave is known as the trough. Trough with a G. Okay. Now, this height, this is a height over here. This height is known as the amplitude. And this is basically the height of the wave. How strong the wave is determined by its amplitude. So as you can see, since it has a large amplitude, you can see the crest is high, the trough is low, and by definition, the wave will be more intense. Okay, now this distance over here is known as the wavelength. That's basically how long the wave is. The distance between two identical points on a wave. So crest to crest. Wavelength could also be measured trough to trough. Wavelength is also trough to trough. And it could also be here to here. Okay, so that's also wavelength. So these are all different wavelengths. So some things to know about waves. So wavelength, okay? Wavelength is not this to this. And if we're using the points at the middle, it's not this to this. That's what some people may do sometimes. It's not this. This is not a wavelength. It's in fact half the wavelength. So you'll end up with an answer that's half the actual wavelength. Now, there's some things about waves that you should know. Right. All right. So some things about waves that you should know is that there's some certain quantities like attached to waves. Okay, so let's just do a quick example. Okay, so if this was a picture of a wave, how many waves are there? Okay, so that's my question to you. Now let's count the number of waves that are actually there. So you get 1 wave, 2 waves, 3 waves, 4 waves, 5 waves. Oh, I'm sorry. I just that we're just sorry for ignore that, but one wave. Okay, now this is how I count them. One wave, two waves, three waves, four waves, five waves, or six waves. So we have 6 total waves here, okay? 6 waves. If I told you the height of the total wave is 2 meters, okay, what's the amplitude? So the amplitude is not 2 meters, okay? The amplitude is the height from the center, the middle of the wave, to either the crest or the trough. So the amplitude instead will be 1 meter. So this is defined as the amplitude. Okay, so now we're going to talk about frequency, and period. A wave's frequency is defined as the number of cycles or oscillations per second. So cycles per second, which is measured in units of 1/seconds, or the hertz. The hertz. And the period is the number, the amount of time it will take for a wave to oscillate once. So for one complete wave. So for one wave oscillation, this is the amount of time it will take. So the period is also defined as 1 over the frequency. To see why, look at this definition. Cycles per second. So if you just take the reciprocal of that, that'll be the amount of seconds per cycle. So 1 over f. That means the unit, since it's a time, will be s, a second. So period is second, and the frequency will be in hertz. So suppose the wave drawing I have up here, okay, this was taken, this was taken on an interval of 6 seconds. So it takes 6 seconds since the wave machine or an oscillator started for a pattern to appear like this. Okay? So A, what is the frequency? So A, what is the frequency? What is the period? So what is the frequency and what's the period? So this is all 6 seconds. So how many waves do we have here? We already counted, okay? So 1, 2, 3, 4, 5, 6. Okay, so you can count crest to crest, or you could count every other time the wave hits the middle. So that should still give you 6. 1, 2, 3, 4. Okay, so that should still, so 1, 2, 3, 4, 5, 6. Okay, that'll give you 6. So 6 cycles, okay, in 6 seconds. Six cycles in 6 seconds. That'll be 1 hertz. Okay, then the period will just be the reciprocal. So 1 over 1 will be 1 second. Okay, so this is yeah, it might seem really easy to you. And you it should be that way. This is not a very hard section. Okay? So now, what you might notice is, actually, it's not really much noticing, but what if you wanted to find out how fast the waves were going, okay? So you want to find V. So how fast a wave moves will be you know, the velocity equation, delta x over delta t. So if you want to find out how fast one wave is moving, let's let delta x equal to the wavelength. So we use the letter lambda to signify wavelength. So lambda over the time it takes for one wave to go through one wavelength. So that's basically the period. Why? Because that is the amount of time the wave oscillates. When it oscillates once, it goes through an entire wavelength. So lambda over the period, okay? What you can do right now is you could separate these two terms, and 1 over period, so that's basically the frequency. Frequency is the inverse of period, just like because period is the inverse of frequency. So you get f lambda. So this is a really important equation you need to keep in mind. V equals f lambda. Okay? So if I told you this length is 6 meters, okay, this is 6 meters. What is the velocity of the waves? Okay, so we already know our frequency, 1 hertz. 1 hertz times, well, what's the wavelength? Okay, wavelength is not 6 meters. That's just the length of the string or whatever this wave is oscillating through. Okay, the wavelength is this distance. So the distance between successive points on one wave. So that is basically 1 meter. That's a sixth. Since we have 6 waves in the 6 meter span, that means the wavelength will be 1 meter. And that gets us 1 meter per second. So that will be the velocity of the waves. Okay. So now we're going to talk about some fundamental, I guess you could say, characteristics of waves. So select and delete. So the first one we're going to talk about is reflection. So suppose you had a reflecting surface, okay? And you send out a wave. So this is a wave. This type of wave is known as a plane wave because it looks like a plane. It's not circular, it's all horizontal. Once it strikes like this, it will reflect. It will reflect off that barrier. So if it hits a reflecting surface, then it will strike back. Okay, so it doesn't actually move a bit. I'm just showing it so you could see better. So it will strike back. And this is known as reflection. Reflection. Okay. So another defining characteristic of waves is what is known as refraction. So reflection, refraction, we'll do more of the math on once you get to like light, but just the basic principle, this is like a thing that applies to all waves, is that you have a wave that's traveling like this at an angle from a not dense medium, so less dense medium, to a dense medium. Okay, so you're actually changing mediums. This is the boundary between the two mediums. Boundary. So once it strikes this medium, it will bend inward. So it will bend inward like that. Okay? And the reason for this is, imagine like a group of people marching. This is 1, This is a line of people. Okay? So imagine a group of people marching. So they're marching, marching, marching. And once they get to this, here, this person right over here, this will start to slow down. But these guys will all still be marching at the same rate. Okay? Then once you get here, this person will be, these people will be slowing down, but these people at the outer edge will still be marching faster. And you see, because of the imbalance of speed during the line, that the line will start to bend inward, which sort of explains refraction. And the reason why we use this marching approximation is that once you can think of a plane wave like this, each point on a plane wave is its own little source of little waves, which are known as wavelets. So each of these waves is a little source, another point wave. So a point wave is basically waves that originate at a single point and spread out like this. And if you draw a line that connects all of these little point waves, you end up with another horizontal line. And as you can see, you could keep on stretching these out with more and more point waves. That's how you can sort of visualize waves, as each point on a wave is its own little source of point waves. And that's why I use this marching line reasoning, is because this point on the wave, okay, will start to these waves will start to travel slower than the waves emitted here, okay, and it will start to bend almost inward. If you were to go from a dense medium to a not dense medium, then the opposite would occur, okay? Let's go back to our marching line. So this person over here at the very outer edge, he'll start walking faster because now pretend a dense medium is mud, okay? He can walk much faster on like concrete than in mud, so he'll walk much faster. However, the rest of his group will still be in the mud. But then this person will start to walk faster. But the rest of the group, the other three people, will still be marching in the mud. And so you can see that these people will start to bend outward. And the same thing applies for waves. Because what we already said about each point on a wave being its own source of point waves, this thing is completely plausible. You can match this thing to actual wave behavior because of this principle over here. So you can see the wave starts to bend outward when moving from a dense medium to a not dense medium or less dense medium. So that's refraction. Okay? So that's reflection and refraction. So diffraction, this is the third characteristic, diffraction. And this is where that principle of each point on a wave being its own little source of point waves comes in really handy once you start to go to diffraction. So let's say at a plane wave, okay, like this. And it passes through a bunch of slits. So single slit. Now things start to get a bit weird. So the wave keeps on traveling, but at this barrier, this section of the wave will just reflect back and will stop and won't move forward. But this section of the wave will. So we'll move like this, we'll move like this. What happens here is, so let's say you had your each little point source of waves along this single plane wave. Okay? So it's emitting wave like this, like this, like this, like this, like this. So these all, if you were to trace a line connecting the waves, you get a wave that's sort of, yes, I have different colors. So, okay, just in case you thought I was using black too much. So yes, you'll start to bend outward and would spread out like this. This is known as diffraction. How the shape of the wave changes because it hits an obstacle. That is known as diffraction. Why? Because the point waves at the very edge, when it creates waves, it has this semicircular part to it. So rather than canceling out with the other waves, it will spread out near the edges, and that's what causes diffraction. Another example would be if we had just a single barrier, had some waves coming in like this. So over here, have your little point sources of waves along the single plane wave. Remember, this is just the same principle we talked about earlier. So they will all create these semicircular waves, but they can be joined together by a straight line. But over here, you could see this part is not straight, okay? This part is not straight. There are no more waves to sort of make this, the part at the edge straight. So it'll start to sort of bend out like this. So we'll diffract. So you don't need to know all the math stuff of this. This is just diffraction. This is the Y of diffraction. So diffraction is basically defined as when a wave basically changes shape, sort of bends outward because it hits an obstacle. So the last characteristic of waves is known as interference. Interference. So suppose you had a string, okay? And he had two wave pulses coming like this. Two identical wave pulses. So when they meet together to form this really large wave in the center, but it won't stay that way for long, okay? This is just for a split second. Why? Because the waves are basically superimposing themselves on top of each other. They're passing through each other. And in the process of passing, when both of them basically meet in phase, meet right on top of each other, this will happen. The amplitude will sharply increase for a split second, but then return like this, and the two waves will just move on to its separate ways. So for the split second, this occurs, and this is known as constructive interference. Constructive interference. So that's constructive interference. What happens if it's like this? Okay, what happens when they're on the opposite sides of the string? Well, for a moment, these two waves will sort of cancel out. This one has like this one will be downwards, this one will be upwards. So the two heights will cancel each other out. Think of this as a negative, this is a positive. They'll add up to 0. So for a split second, the rope will look like this while the two waves pass through each other. But that doesn't mean the waves disappear. After that split second, the waves will sort of reform like this. So it'll reform like this, and it'll just go in the opposite directions. So that is what is known as destructive interference. Destructive interference. Okay. That is what's known as destructive interference. Okay, so those are the four defining characteristics of waves. Those hold true for all waves that you can imagine of. So if it's a wave, it can do these four things. Okay. So now we're going to get to another topic. Or you know what? I'll save this for another video. So we're going to split this unit into parts. Sort of 3 parts. This will be waves. In the next video, we'll talk about simple harmonic motion, how it sort of connects to waves, but really doesn't. So that'll be on our next video.